Your phone knows where you are, because time is literally different in space. No, really, if Einstein were wrong, your GPS would be off by miles, and you'd end up at a dentist instead of Taco Bell. Satellites up there experience time slightly faster than we do down here, and your phone has to correct for that tiny time warp just to find your location. So every time you order a Crunchwrap Supreme, you're casually relying on relativity, atomic clocks, and a swarm of space robots. Hungry yet, or just existentially confused? Your phone is secretly a stopwatch with commitment issues, because the entire GPS system boils down to one weird trick: measure time so precisely that it becomes distance. Every GPS satellite is constantly shouting, "The time is exactly this much o'clock," and your phone listens for those signals like someone trying to hear their name in a crowded bar. The signal travels at the speed of light, which is about 300,000 kilometers per second, so even a tiny delay, like a few billionths of a second, means you're kilometers away from where you think you are. Your phone grabs signals from at least 4 satellites and does a kind of cosmic triangulation, except it's actually trilateration because math likes to be pedantic. Each satellite gives you a sphere of possible locations, and where those spheres intersect is you, standing outside a Taco Bell, pretending you're just checking directions. The wild part is your phone isn't measuring distance directly, it's measuring time and converting it using the speed of light. Like, this signal took 0.00007 seconds, therefore, you are exactly this far away. It's basically turning the universe into a giant ruler made of time, and all of this happens in milliseconds while you're wondering if you should get a Crunchwrap Supreme or make better life choices. If GPS had a villain, it would be bad timing, because being off by just 1 microsecond, 1/1,000,000th of a second, would throw your location off by about 300 meters, which is the difference between you're at Taco Bell and you're in a lake questioning your decisions. That's why GPS satellites carry atomic clocks, which are basically the divas of timekeeping. These clocks measure time based on the vibrations of atoms, usually cesium, which vibrate at a frequency so consistent it makes your phone's clock look like it's guessing. We're talking accuracy to within a billionth of a second. Your phone, by contrast, is like, close enough, which is why it relies on the satellites to tell it the exact time. The system works because all the satellites are synchronized, like an orchestra where every instrument is obsessed with being on beat. If one satellite's clock drifts even slightly, your calculated position starts to slide around like you're on a GPS Ouija board. So every time you open a map app, you're depending on a network of orbiting atomic clocks screaming hyper-accurate timestamps down to Earth. It's less like asking for directions and more like consulting a team of extremely punctual space librarians. Here's where things get delightfully ridiculous. Your ability to find tacos depends on Einstein being right. According to relativity, time is not the same everywhere. Clocks in stronger gravity, like here on Earth, tick slightly slower than clocks in weaker gravity, like up in orbit. Meanwhile, satellites are also moving really fast. And special relativity says moving clocks tick slower too. So you've got 2 competing effects. Gravity makes satellite clocks run faster, motion makes them run slower. And the result is that satellite clocks end up ticking about 38 microseconds faster per day than clocks on Earth. That sounds tiny, but remember, light is fast, so that tiny difference would mess up your position by about 10 kilometers a day if uncorrected. 10 kilometers! You'd be confidently navigating to Taco Bell and end up at someone's wedding reception instead. Engineers actually have to pre-adjust the satellite clocks to account for relativity, which means every GPS satellite is basically running on Einstein-corrected time. So yes, when your phone says turn left in 200 meters, it's because we applied early 20th century physics about space-time curvature to your late-night snack run. Science is not subtle. 3 satellites might sound like enough after all. 3 points define a location, right? Wrong, because your phone's internal clock is about as trustworthy as a microwave timer. GPS solves for 4 unknowns: your position in 3 dimensions, latitude, longitude, altitude, and your phone's clock error. That's why you need at least 4 satellites. Each satellite gives you a distance based on signal timing, and your phone basically says, okay, where could I be that matches all these distances? With 3 satellites, you'd get a rough position, but your clock error would throw everything off, like trying to bake using a stopwatch that randomly adds minutes. The 4th satellite acts like a reality check, letting your phone solve for both where you are and how wrong its clock is. It's like asking 4 friends what time it is and then adjusting your watch based on the consensus, except your friends are in space and extremely judgmental about precision. Once your phone locks onto those 4 signals, it can pinpoint you to within a few meters, which is just accurate enough to tell you that yes, you are indeed standing in the Taco Bell parking lot. And no, there is no shame in that. If GPS is so precise, why does your little blue dot sometimes wander like it's had too much coffee? Because the real world is messy, and radio signals don't travel in perfect straight lines when they hit stuff. Buildings, trees, even your own body can block or reflect signals, causing what's called multipath error, which is a fancy way of saying the signal bounced around like a pinball before reaching your phone. That extra path makes the signal seem like it took longer to arrive, which makes your phone think you're farther away from the satellite than you actually are. So suddenly your phone is like, you're in the street, or maybe inside this building, or possibly living your best life inside a Taco Bell kitchen. Urban areas are especially chaotic because signals ricochet off skyscrapers, turning your location into a best guess rather than a precise answer. Engineers use clever algorithms to filter out bad signals, but sometimes your phone still gets confused and decides you're jogging across rooftops. So the next time your GPS acts weird, it's not broken, it's just trying to do relativistic time calculations while signals bounce off a glass building and your arm is blocking half the sky. Cut it some slack. It's doing physics at you,